I made a video once about how I no longer had interest in Zig because the developer had given signals that they were into the woke thing. And a commenter replied that they're glad people like me are on the way out, blah, 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 blah. And I think that it shows how short-sighted a lot of young programmers are today. A lot of you are trying to learn Rust, or you're trying to learn whatever the language du jour is today. You're trying to learn things that have heavy abstractions like JavaScript and, HTML, CSS, the DOM, all of that. And a lot of you look at C as this archaic thing that, that just needs to go. We just need to rewrite it all in Rust, which is modern because, the fallacy of new things. Somehow it being newer makes it better. Or we could just write it in Python. Why do we have to have this in C? Because Python's easier for you to code in. I can get so much more done, even though Python is slower. Even if you use C Python, it's still several times slower than actual C. So I think that what's really important about this is that a lot of young programmers, a lot of aspiring programmers, a lot of people who have been in a, shall we say, high-level abstracted industry, such as JavaScript programming for years, the kind of programmers who think everything could just be a web app and it would be fine, they're very quick to write off C. Rust programmers also are very quick to write off C because it's unsafe. But I think what they don't understand is that C is not some sort of it's not a fun language. It's not something that was designed to be enjoyable. It's something that lets you work with a machine-independent assembly language. It's basically a layer above the bare metal. It abstracts out just enough that you can work comfortably without spending all your time in a quagmire of register management. And that's the crucial thing about it. But what else is crucial with C is that it doesn't hold your hand in any way. Rust holds your hand through the borrow checker. Languages like JavaScript or Go or whatever, they hold your hand through garbage collectors. I don't have to manage my own memory. Well, that's great, but at some point, you are going to pay the toll. Garbage collection is a toll, and it is a heavy toll. In any of these managed languages, they are managed to speed up developer time at the expense of abstraction complexity. C does not have abstraction complexity. It does, but it's not enough to really point at it and go, yeah, abstraction, because C is meant to be a high-level assembly language at its core. And what we are losing with new programmers shunning C in favor of Rust, in favor of all of these popular new languages, whatever the new language is this month or year or whatever, is that they're not thinking in these low-level terms anymore. A lot of programmers, even if they write code in C, they're not learning about what the machine is doing under the hood. What C does for you that no other language does is actually force you at some point, if you want your program to perform well, to understand how your machine works. With C, you think about cache lines. You think about performance. You think about the way that the processor works. You think about branch prediction. You think about the prefetcher, because these things affect how your program works at scale. Now, if you're writing a hobby program that asks your name and says, hello, name, of course, you're not going to worry about that. But when you get into the weeds with some tool that you're writing to make your life easier, like I did with JDupes, which is a duplicate scanner, I think about ways I can make it faster. Where are the pain points? Why is this not finding this faster? It was fine when I had 5,000 files I pointed it at, but I have some folders at this point that I've produced 1 million files of data. I have users with databases that have several millions of files of data. And at scale, it becomes a problem. What worked for 1,000 files doesn't work for 1 million files. C forces you to address that directly and head on and understand the underlying architecture. Even more importantly, C has been grafted onto the standards revised over time so that you can use the new features of that specific architecture. Everybody wants to hide the machine, and that's the problem. With C, even though it's hard, it gives you full access. So here's an example. A whole lot of things would be way faster right now if they just took advantage of vectorization. No, GCC or Clang will not auto-vectorize most things for you. You might think they will, but they're very cautious and conservative, and in the vast majority of cases, they simply do not. Simple primitives like, oh, well, I'm writing my own memory copy. Yeah, they'll swap out your loop for a predefined vectorized memory copy. Okay, that's all fine and great. But at the end of the day, if you're doing, say, string comparisons or substring searches, you can pull those strings 32 bytes at a time into an AVX register, do masked comparisons, and scan 32 bytes at a time, whereas on a modern 64-bit machine, if you're just chewing through it, you're doing it at most 8 bytes at a time in a 64-bit register, just a standard scalar register. But you wouldn't know any of this if you're a Rust programmer or if you're a JavaScript programmer, because you're being pushed away from the metal. This is not something that you would normally think to do. You are constrained by the abstraction. You do not have access to these low-level primitives the same way you do with C. Now, granted, writing AVX code in C is clumsy, but at the end of the day, it's just assembly language. And you're shoving little assembly bits in C that you stitch into the C code. But you're not going to be doing that with Rust. Rust encourages you to be safe. You know what's unsafe? Assembly language. Super unsafe. In fact, it's the least safe. You can literally emit assembly instructions to do whatever you want, including trigger a page fault in your program that causes your program to crash instantly. So every language that's not C generally encourages you to stay away from the true nature of your computer. And because of this, you have people doing string comparisons using scalar registers at best, if not decomposing it into byte for byte checks. They don't ever even think in terms of vectorization, much less understand how to do it. They don't think about branchless programming or how to do it. They never learn these paradigms that are the fastest way to get things done on a computer. And it's fine when it's your duplicate scanner scanning 100 files. The formula for taking a set of 100 things or whatever and comparing it to every other thing in the set is n parenthesis n minus 1, close parenthesis, over 2. Basically, if you've got 100 things, it's 100 times 99, which is 9,900, divided by 2, which is 4950. You have to do 4,950 comparisons to compare 100 files, all of them against each other. When you scale that up, you start seeing numbers that are astonishing, eye-watering. For 100,000 files, what's 100,000 times 99999? That's a lot of comma separators, because that's a lot of places. And at that scale, every single thing that you can do, for example, if you can cut half of that data set, that's a big win. If you can chew through that data set 32 bytes at a time instead of 8, that's an almost 4 times speed up. If we ignore the realities of hardware, in processing terms, pure processing terms, just vectorizing can be a 4 times speed up. But you know what you don't do in Rust or JavaScript or whatever other modern language? You don't write vectorization assembly for your x86-64 CPU or your ARM Neon CPU. You just don't do it. The only people who do it are weirdos like me, the very people that you, my young, poor, miserable, young, aspiring programmer friend, have said you're glad are on the way out. If I didn't vectorize that stuff under the hood for you, you would never get those advantages, because who else is going to do it? You're not going to do it. Your friends aren't going to do it. None of you even know about vectorization, much less care about it. So anyway, before you go saying that you're glad people like me are dying off and on the way out, retiring to a yacht somewhere, before you say that all the John Carmacks of the world that made Doom, well, yeah, they were great in the 90s, but I'm glad that they're leaving so a bunch of new young people can take over with our much better ways, I would encourage you to step back and realize that what you're doing is trying to graft on your little carpentry class wooden deck at the top of a house that I built for you, that people like me built for you to staple gun your amateur carpentry deck onto. That's what's going on. And yeah, that house will last a while, but one day that house will rot away that code will no longer work on the platforms that are coming out. Someone's got to write the new code to work on the new platform. Someone's got to optimize it. You're not going to do it. You're too busy writing safe code that's abstracted away from that pesky, annoying hardware reality. But at the end of the day, you're running on that hardware. The hardware reality is the reality. Everything that you're doing, you're lying to yourself. You're lying to others. It's all just one big abstraction sandwich, and you pay the toll every time you flip that power switch. So maybe step back and have a little bit more respect for the people who built the house that you're doing your little carpentry project on top of and announcing how bad houses are. Thanks, bro. Swear to God, these youngins got no riz. Mad, no cap. Anyway, that's my Gen Z slang for the week. Take it easy, and I don't wish death upon you like you do me, because hopefully 1 out of every million of you will hear the word vectorization come out of my mouth, and you'll look into it and realize, holy crap, I can do some really cool stuff, and it's actually not that hard. It's a different way of thinking, but it's not as hard as I thought. Maybe enough of you will be around to build more programming houses. We can only hope. In the meantime, I'm going to go back to dying, because that's what we're all doing. And I hope this has been interesting. Take care.